The topic of our discussion in this video tutorial is transformation of functions. First, we will discuss that if we add and subtract from the input and output of the function, how the graph of the function will transfer. So let's suppose we have a function y is equal to fx. So y is the output and x is an input. What will happen to the graph of the function if I will add something in the output? So addition, if I add or I subtract, what will or how the function graph of the function will change. To demonstrate this, I'm gonna take this example. I have a function y is equal to x square, or f of x is equal to x square is just simply, you can also write it as a y is equal to x square. And if I add in the input, as you see that this is the whole output of the function, and I add 1 in the output. So if I add something in the output, let's see how the graph will change for that function, or what will be the graph of this function. So if I plot the graph of x square plus 1, this will be the graph of the function. It will be the exactly same graph, but it's a shift upward, a shift up 1 unit. So whatever I will add in the output, it will shift the graph upward. And also let's take another example, which is x square minus 1. What happens if I subtract, instead of adding something in the output, I subtract 1 from the output? In this case, the graph will not change, except it will move downward 1 unit. So it is a moving down 1 unit. So in summary, if you have the function y is equal to fx, if you add or subtract some things in the output, so addition will move up and the subtraction will move down the graph. Now let's talk about the input. So we know that we have the function y is equal to fx, and now x is the input. How the graph will change if I will add something or subtract something in x. X is the input of the function. So let me again first draw the graph of the function. So this is the graph of the function y is equal to x square. And now I'm gonna draw the graph of the function y is equal to x minus 2. Here you can see I'm subtracting 2 from the graph of the function, from the input of the function. So this is going to be the new graph. This is the graph of the function y is equal to x minus 2. This is a 2. So what happened? The graph shift 2 unit to the right. So that happened if you subtract, graph move 2 unit to the right. Let's take another example. What will be the graph of x plus? What if you add 2 in the input? In this case, let me again plot the graph. So this will be the graph, exactly the same graph, but it shift to the left. So again, in summary, if you add, which is the y is equal to fx plus c, is going to shift in the right. Sorry, if you subtract, it's going to shift in the right. So if you subtract, it's going to shift in the right, and if you add, it is going to shift in the left. So it's very important. Subtraction move the graph to the right. However, the addition move the graph to the left. Now let's talk about multiplication. What happens when we multiply to the output? or we multiply to the input. Again, first we're going to talk about output. For example, if we have a function f of x, then what happen if I multiply the whole entire function by a constant c? For example, here, if I draw x-axis, y-axis, the graph of my function is this. The y is equal to 2x square. Oh, sorry, y is equal to x square. This is the graph of the function, the original or parent function. What will be the graph if I multiply 2 to the output of the function? It will stretch. It will shrink in the x direction, or we can say stretch to the y direction. So it can basically is shrinking this way or stretching that way. So these are the same operation. However, if I take another example, y is equal to 1/2 x square. So now I'm also multiplying 1/2 to the function, but this time the behavior will be really opposite. This will be the graph of the function. In this case, a stretch basically is not happening. In this case, the function is moving in this direction. It's a dilating in the x direction, and it is expanding in the y direction. So it is expand and it is basically dilate in the x direction. So the reason is that if the constant c is a less than 1, this is gonna make the function to stretch in the x direction, I would say, but dilate in the y direction. But if the c is bigger than 1, this is going to be stretch in the y direction. So these are the two things about multiplying the constant outside the function. So if the constant is a bigger than 1, is going to make the function smaller in the y direction. But if the constant is less than 1, then it's going to make the function bigger in the y direction. How about the input? The input is going to be a very similar situation, but it's going to be a totally opposite. So if you have y function and then you have to multiply the x inside the function, this is sort of multiplying the c inside of the function. Almost same thing is happening, because if the c is bigger than 1 here, c is a bigger than 1, which is a 2, the function is going to uh, shrink, I would say, or stretch in the y direction. This is the function y is equal to 2x square. And again, if I choose f of x is equal to 1/2 x square, is gonna do the dilation in the y direction actually, or x direction. But that will be the graph of y is equal to 1/2 x to the 2. It's almost happening the same sort of the operation. The function is stretching when you're multiplying the constant which is a bigger than 1, and if you multiplying to the constant which is a smaller than 1, the function is dilating in that direction. Now let's see what happens when you multiply by a negative number or a negative sign, or when you switch the negative sign of the output or to the input. Again, let's draw the graph. The function y is equal to this. This is a y is equal to x square. Simply, if I multiply by a negative number, what will happen? It will flip the graph. This is a y is equal to minus x square. What is going to do is going to flip the graph. So if you have y is equal to fx, and then you multiply negative to the output, f of x is the output, it's going to flip the graph over the x-axis. This is a x-axis. Now let's check what will happen if you do that for the input variable. So to the input, I'm gonna take a different graph this time to explain. Otherwise, this is not gonna look anything, change. So now the graph of this function is this. This is the graph of y is equal to x cube, you know. And if I multiply to the inside of the input, to the input, negative sign to the input, what is going to do is gonna flip this time the graph on the y-axis. This is the graph of y is equal to minus x cube. So as you can see, along the y-axis, the graph has been flipped. So this graph flipped along the y-axis on this axis. So in short, if you multiply to the output, graph is going to flip over the x-axis, but if you multiply negative sign to the input, graph is going to flip over the y-axis. Here I have all the basically discussion which we discussed in the video, that if you add, subtract, multiply, how these operations are going to stretch or expand, move up and down, and reflect the graph of this function. So this is a very useful table for to review this video. So this is also the end of this video tutorial. Thank you very much for watching. I will see you in the next video. Bye for now.